Today we're going to move on to factoring trinomials in the form of x squared plus bx plus c, where c is positive. And that might sound really complicated, but in truth, it's simpler than you think. First of all, let's look at this pattern. Notice there is no coefficient of x squared, which means we can assume that coefficient is 1 x squared. Also, we have to assume that c is positive because if I just have a variable c here, it means it could be positive or negative. But we're really looking at trinomials that look something like this. Here's an example. X squared plus 5x plus 6. Oops, 6. Not c, 6. So you can see that 5 is in the place of b and 6 is in the place of c. Their coefficient of x squared is 1. So, although the title of this might look a little daunting, it really isn't. I do want to say that this term with an exponent of 2 has a special name. It's called the quadratic term. And we're going to use that word quadratic quite a bit this year. But quadratic term just means the exponent is 2. The 5x also has a special name. It's called the linear term. And it's called the linear term because its exponent is 1. Okay, with that settled, let's move on and look at a specific example. I'm going to get there by first multiplying. Let's say x plus 3 times x plus 4. We know that when we multiply binomials, we can use our handy-dandy FOIL method. First multiplying the first terms. That gives x squared. The outer terms are 4x. The inner terms are 3x. And when we add those together, we get 7x. The last terms give us 12. So, as we look at this trinomial, what we're going to be doing, see, this is in the pattern of x squared plus bx plus c, where c is positive. In this case, b is 7 and c is 12. Let's pretend that we didn't just FOIL this, multiply this together. Let's just look and say, okay, if I'm drawing my parentheses, what must go here and here if the first terms multiplied to give me x squared? That's pretty simple. We know that that's x and x, because that's the only thing that could give us 1x squared. The other two clues come with the number 7 and the number 12. We've seen over here that the number 7 came from adding the 3 plus 4, and the number 12 came from multiplying the 3 and the 4. So what I'm looking for in these numbers are numbers whose product is 12 and sum is equal to 7. And even if we hadn't just done this, I think most of you would be able to say those numbers are 4 and 3. So that leaves us with the issue of what signs go in these binomials. The point of c being positive is that when I am FOILing, if the way that I get this the sign for c, this plus sign here, is by multiplying the two numbers. What it means, if when I multiply numbers together and I get a positive, that means the signs are the same. This plus sign here in front of 12, c positive, doesn't mean these signs are both positive. It means that they're both the same. And since when I added them together, I got positive 7x, that means they're both positive. So C positive means the signs are the same, and the sign of B tells us what they are. Okay, so let's start out easy. Let's say x squared minus 8x plus 15. When in doubt, draw parentheses. We're going to draw the parentheses. And we're going to put in the variables because that part's easy. If the first term's f multiplied to give me x squared, then one of them is x and the other one is x as well. When this sign is positive, it tells me that the signs in the two binomials are the same. In this case, they're both negative. And when we multiply this back out, I'll show you why that has to be. Now, in terms of numbers, I know I'm looking for numbers that multiply to 15 and add to 8. And clearly those are 3 and 5, and it doesn't matter if I put the 5 in the first one and the 3 in the second one, or vice versa. It still is the same, because x minus 3 is a number. And if I multiply it by x minus 5, it doesn't matter what order. Now let's just FOIL it back so you can get the idea. First gives us, as we knew, x squared. The outer is negative 5x, and the inner is negative 3x. When I put those together, here, let's move this down a little. When I put that together, I get negative 8x. But when I multiply negative 3 times negative 5, it gives me positive 15. When this term is positive, when the product has c as a positive term, that means these signs are the same, and they are both whatever this sign is. Sometimes there's a little bit more complexity in the variables. If I say that x squared plus 9xy plus 14y squared is my trinomial, I'm going to begin by drawing parentheses. I'm going to put in my variables. Clearly, x times x gives me x squared. But what would make the last term have a y squared? Well, since this whole term comes from multiplying my last in FOIL, you can see that each of these needs to have a y. After that, we do exactly what we've been doing. When this sign is positive, here, it means the signs are the same, and they are both what this is, meaning they're both positive. I'm looking for numbers that multiply to 14 and add to 9, and clearly they are 2 and 7. Sometimes it's confusing at first to understand how come that became xy. Well, let's FOIL it and see what happens. First gives me x squared. Outer gives me 7xy. Inner, here I'll show you that, 7xy. Inner gives me 2xy. So together they give me 9xy, and that's where the xy comes from. Last gives me 14y squared. When I'm adding my like terms, the exponents stay the same. When I'm multiplying 2y times 7y, I have to add my exponents. I know it's a lot to keep in your heads, but I think you're pretty good at exponent rules at this point. Occasionally, the trinomials come in the opposite order. If I say 35 minus 12x plus x squared, it's the same basic idea, but now I'm putting things in a different order. Last gives me x squared, so my variables go here and here, because that's where the x squared comes from. This sign still tells me that the signs are the same, and it still means that they're both negative. And I'm still looking for numbers that multiply to 35 and add to 12. They are 7 and 5. And just to make sure this works, let's FOIL it. First gives me 35. Outer gives me negative 7x. Inner gives me negative 5x. Together, that's negative 12x. And then plus x squared. Sometimes you might see something like x squared plus, oh, I don't know, let me see. Let's say 15x plus 54. So I'm going to start the same way. Draw in my parentheses, put in my variables. This sign tells me they're the same. This tells me they are both positive. I'm looking for numbers that multiply to 54 and add to 15. 54, oh, I did this by accident, but 6 times 9 is 54, and 6 plus 9 is 15. Okay, just more practice. See if I can make up a better problem to talking about. Okay, so x squared plus 16x. Nope, that's not going to work either. Okay, well, we'll do it anyway. Plus 16x plus, I don't know, let's just say 12. Okay, so I'm looking for numbers. Here's my x and my x. Sign tells me they're the same. They are both. I'm looking for numbers that multiply to 12 and add to 16. Well, 1 times 12 is only 13. And from there, it's going to go down. So there is 1 times 12, 1 plus 12 adds to 13. 2 plus 6 adds to 8. So there is no such combination of binomials. Therefore, this is a prime trinomial. The one last thing that I want to encourage you to do is sometimes it's not that obvious. If I say x squared plus 27xy plus 72y squared, I can always start out with the givens, and that's easy. I know that I'm going to have to put an x here and an x there, a y here and a y here. Now I know I'm looking for numbers that multiply to 72 and add to 27. And for many of us, that's not going to be that obvious to begin with. So when you get stuck, list your factor pairs and then check to see which ones add up to what you're looking for, if any. If none do, then it's prime. So 1 times 72 is 72. 1 plus 72 is 73. Doesn't work. 2 times 36 is 72, but 2 plus 36 is 38. Doesn't work. 3 times 24 is 72. 3 plus 24 is 27. So that means I know my numbers are 3 and 24. I know that because of this sign, it tells me that the signs are the same, and they are both this. Well, we haven't done many negative ones, so let's make this negative instead. Okay, this sign tells me that they're the same, and this tells me what they both are. And if I were to multiply this out, I would see that I did it right. X squared minus 24xy minus 3y gives me negative 27xy plus 72y squared. So let's summarize for factoring x squared plus bx plus c, where c is positive. The first thing you want to do is just draw your parentheses. And then place your variables, front and back if necessary. I find that kids pretty much understand this, so we don't have to go into the details of this. Here's where it gets a little bit harder. When c is positive, it means both signs are the same. And what they both are, they're both the sign of b. And then finally, I'm looking for numbers whose product equals C. Remember, that's what it is when you multiply. And the sum equals B. Once you get the hang of this, it's really pretty much fun. It's just like solving a puzzle. So good luck.